Yes, class. Am I audible? Devagi, Aram, Fatima, Ma. Are you able to hear?
Yes, ma'am.
Alright. So, C class. In the last class, we had started with vectors. So, Devangi, regarding your topics that have been left or that have been missed before you joined, that we'll discuss later on, the timings and all, so that you can join the classes. Initially, we had started with, we have completed the first lesson, that is motion in a straight line and dimension analysis. So that backup that I'll provide you. But there's one more student along with him. I'll provide that backup to you. Now we had started with vectors. In vectors, for you, parallelogram law has been over. I'll do parallelogram law most probably tomorrow with you. So parallelogram law, though it is over, but the solving part or the formula for parallelogram remains the same for every law. So even if you just remember what's the law, you'll be able to solve other questions as well. So remember, if two vectors are there, do you understand what are vectors? Vectors are what? Vectors are those quantities that have a magnitude as well as they have a specific direction. That is what is meant by a vector quantity. Magnitude plus direction plus they obey vector laws. So here what happens, they obey vector laws. Now those vector laws we have to discuss. So three laws are there: parallelogram law, triangle law, polygon law. Triangle law and polygon law, these two law, the triangle one and the polygon one, we'll try to complete in today's class. Parallelogram law has been over. So that derivation and all those small little things that are added up in that we'll discuss it later on, Devangi. Now for others, in the last class we had started, we have already completed Cartesian form addition and now we were on polar form. So for polar form, as I've mentioned, that three laws are required: the parallelogram, triangle law and the polygon law. Now from here, inverse trigonometric function we have seen, questions we had seen. Till here only we had done. Fine. Now there are certain special cases. Firstly, let me repeat the formula once again. See, the resultant's magnitude, the magnitude of the resultant, this is given by what? One vector is A, let's say other vector is B. It may happen that Devangi will not be able to understand certain things, so just ask me wherever you're not able to understand, because these topics I have not done with you. And regarding the backup classes, as I've said, that will be arranged. Because certain topics are there that you have to, for example, integration is left. So integration, I think Fatma, Maha, yours is also left. Differentiation we did. So those classes we'll have. So resultant is what? A square plus B square plus 2AB cos theta. This is the resultant of the two vectors. Fine, if you have two vectors. Similarly, in the initial part only here, this that was written tan beta. Tan beta was actually what? Tan beta means if that angle gives you the direction of the vector. Magnitude is given by this formula. Direction is given by this. This is B sine theta divided by A plus B cos theta. Now, what is meant by B and A over here, I'll repeat. For example, a vector B is here, a vector A is here. And these are representing the adjacent sides of a parallelogram. So their resultant is given by the diagonal of the parallelogram. This is the law. This is the main statement of the law. And the angle between them is theta, that we consider no cos theta, sin theta. That is actually the angle between vector A and B. While beta is the angle that the resultant makes with the A vector. This is beta. Fine. Now there was certain special cases that I wanted to discuss with you all, which were left in the last class. First case, you people were in a habit of using, if two vectors are given and they are in opposite direction, even when you calculated the formulas for relative velocity, what did we do? We just subtracted them or we just added it. So if velocity is a vector quantity, then in case of relative velocity also, we should have kept the vector laws in mind, but we did not do that. If two vectors were in opposite direction, we just subtracted them. If they were in the same direction, we added them. So why did we do that? Reason is that, see, three cases we'll see. And class, don't note it down when I'm writing. I'll give you sufficient time to copy all these points. So case one is when the angle between the two vectors is 0 degree. It means both the vectors are parallel. This is A vector. This is B vector. So the angle between these two vectors is what? The angle between these two vectors is 0 degree right now, because they are what? These are parallel vectors. Now put 0 degree in the main formula that you have. So this becomes what? Resultant becomes what? A square plus B square plus 2AB cos theta. This is the main formula. Instead of theta, just put 0 degree. So this becomes A under root A square plus B square plus 2AB cos 0 degree. And we all know cos 0 degree is what? 1. So we are left with what? Under root A square plus B square plus 2AB. And this becomes 1. So only this much is left. Now notice something. A square plus B square plus 2AB. Are you able to identify any kind of identity from here? A square plus B square plus 2AB. Anyone?
A plus B square?
Yes, both are right, Aisha and Neeram. It's A plus B whole square. So R can be written as under root is here. This term can be written as A plus B whole square. This square is what? Square is ultimately something to the power half. So this term to the power half gets cancelled. Resultant is what? A plus B. That's why whenever two vectors were in the same direction, we used to add it directly. Even in your lower classes, see, vectors is very essential. Without vectors, you'll not be able to do physics. So please pay attention to vectors. I need, see, your class got postponed, no? Monday we didn't have a class, yes. It was raining heavily over here in Delhi. So I couldn't reach home that time. So I had to shift the class very late. So we'll have the same class on Friday. Exactly, we'll have the same class on Friday. So one class is needed for resolution of vectors and then dot product and cross product. After that, you will be having a complete test on vectors. The way you had a test on relative velocity last time, this time the topic is vectors, complete vectors. So start studying it. So resulted is A plus B. So that's why whenever two vectors are in the same direction, we used to add it. Or even in your lower classes, when two vectors were given, you never had even the thought of adding them vectorically. You just knew that these are vector quantities, but adding them vectorically, you didn't know. So why did we add it directly? That the reason is this, because when 0 degree becomes, cos 0 becomes 1, and you get the resultant as A plus B. Take another case. Take case 2 where theta is 180 degree. 180 degree means anti-parallel. Anti-parallel means if A vector is pointing towards the right side, B vector will point towards the left side, opposite. This is known as anti-parallel. Or even it can be one thing upward, other thing downward. This is known as anti-parallel. So in the formula of resultant, A square plus B square plus 2AB, cos theta, this time it is 180 degrees. Cos 180 is minus 1. So R becomes what? A square plus B square. This is minus 1. So minus 2AB. Now can you see another identity once again?
A minus B whole square.
A minus B whole square. Perfect. So this becomes under root A minus B whole square. This square cancels it. So this is A minus B. That's why we used to write whenever we did questions on relative velocity as well. That time we used to write both the vectors which were acting in opposite direction. We used to directly subtract it. The reason behind it was this only. That when you subtract two vectors, basically the angle between them becomes 180 degrees. And when you put 180 degree in the formula for the parallelogram, you get the answer as A minus B synchrony. So that's why when any time two things are in opposite direction, we just subtract it, and when two things are in the same direction, we add it. One more case you should remember, because that will make your questions and solving of numericals become very easy. Last case that we'll discuss, see, other cases can be any. You can have 120 degree angle also, 60 degree also, 30 degree also. Then some different angles like 53, 44, like these, any angles you can have. Most probably in exams, the angles are given in such a way whose value you are aware of. Like to the max, just remember the value of cos 53 and sin 53. Apart from this, 30 degree, for these 45 degree, 60 degree, 90 degree, 0 degree, these are sufficient. Questions come from here. Case 3 is when theta is 90 degree, means perpendicular. This is what this is meant, that this is perpendicular. It means this is B vector, let's say, and this is A vector, and both of them are making angle 90 degree or pi by 2 with each other. Now see, under root A square plus B square plus 2AB cos theta, instead of theta write it as cos 90 degrees. So cos 90 is what? Cos 90 is 0. So this whole term, this will be 0. What are you left with? You are just left with r is equal to under root A square plus B square. Now, why am I saying remember this? Because 90 degrees case is often used and often asked in the exam. So especially if you're aware about the result, like question will be there, a force is acting perpendicularly to another force of 4 Newton magnitude, like this. So instead of every time you are calculating this, putting the cos 90 as 0 and again surprising yourself that your answer is under root A square plus B square, it's better if you remember this at once. Now regarding other angles, 60 degree, 120 degree, that with time you'll be able to do. But I think these three cases are enough, especially the first two cases are needed for your theoretical questions, that why do two vectors are added or subtracted. Case 3 is needed for your calculation perspective. Case 3 is required from your theoretical numerical questions, and case 1 and 2 are required from your theoretical questions. So note these three cases.
Ma'am,
Yes.
ma'am, for the term 1 examination for physics will be on 17th of September.
17 and
Today.
first three chapters.
Yeah, first 3 chapter.
Okay. I'll see. Let's see. Vectors will be completed. Projectile motion will be started, but definitely it will not get ended by 17th, I think. 17th or 18th? Ira?
17th of September.
17th. That's Saturday.
Saturday. Yeah.
Alright, fine. So before that, I'll arrange a class for you and Aisha. Aisha, you're in the same school, no, with Aram.
Yes, ma'am.
So vectors will be over because we are towards the end. Major this was the parallelogram law, resolution, cross product, dot product. These topics are left. Triangle and polygon law that we'll do today. So after vectors, I'll start with projectile motion, but obviously maximum things will not be covered. I need an extra class with you. So that time I'll discuss it. And Devangi, what about you? What's the physics lesson currently going in your school? You must not be having your summer vacations, no? Yes, Devangi.
No, ma'am.
Your school is going on. No. So what is the physics syllabus right now in your school?
Ma'am, first 3 chapters are done. Chapter 4 is going on. Motion in a plane.
Motion in a plane is going on. Fine. See class, this question says what? This says that greatest and least resultant of forces of two forces. Greatest and least means what? Two forces sum maximum value together they can have is 29 newtons. It means two forces are given to you, and greatest value two forces can make in which sense? If you add both of them, then only you can have a greater value. So it means, let's say F1 is the first force and F2 is the second force. So F1 plus F2 will be 29 Newton. Fine. Greatest resultant of two forces is 29 Newton. Secondly, it says least resultant of two forces is 5 Newton. It means least resultant means what? Minimum value the two forces can provide. And how can two forces provide you a minimum value? Two forces can provide you a minimum value if they are subtracted from each other. So here you will have F1 minus F2 will give you 5 Newton. This is what is meant by the first two lines of the question. Greatest and least resultant of two forces acting at a point are 29 Newton and 5 Newton respectively. Now, if each force is increased by 3 Newton, if you increase both the forces by 3 Newton, then resultant of the two force, find the resultant of the two force and angle is given to you right angle. This question is not at all tough, just understand. First two lines are clear. Two forces are adding and giving you one result. Two forces are subtracting and giving you another result. Now, if you look here carefully, using these two equations, equation 1 and equation 2, you can easily find out the values of F1 and F2. So before we even begin further discussion, let us just find out the values of F1 and F2. If you add over here, F2, F2 will get cancelled. 2F1 will be equal to 34, right? So F1 will be equal to what? 17 Newton. This is the value of F. Clear? Now here just put in the values of F2 as well. In any of the equation, if you can put, if we put it 29 minus 17 is what? 2, 1, 12, right? So if you put it in the first equation or any equation, F2 will come out to be 12 Newton. So using 1 and 2, you have the values of F1 and F2. So that's why the first two lines of the question was mentioned. Now it says if each force is increased by 3 Newton. Let's write the new forces. Each force is increased by 3 Newton. That means F1 prime is a new force. That becomes 17 plus 3, which is equal to 20 Newton. And F2 prime becomes equal to 12 plus 3, that is 15 Newton. Now you are concerned with what? 17 and 12 have now vanished for you. You are just concerned with 20 Newton and 50 Newton. So it says, the question says what? It says if each force is increased by 3 Newton, means 20 Newton and 15 Newton right now, you have to find the resultant between these two forces if they are at right angle to each other. So now the forces are given to you as F1 is what? See, F1 prime is 20 Newton, F2 prime is 15 Newton, theta is 90 degree. Third case we'll use. Directly write down the resultant as F1 square plus F2 prime square actually. Don't write F1 and F2's initial value before adding 3. Don't write 17 or 12, write 20 and 15 because this is the value that you are required to use. Now class, if you use the normal parallelogram formula, then you have to write that additional step 2F1 plus F2 cos 90. Then you have to put cos, then you have to realize the fact that cos 90 is 0. So you are just complicating your answer. It's better write down from here only. Now RB resultant will be equal to what? 20 whole square plus 15 whole square. Yes, 25 Newton exactly. They are, I think, forming a Pythagorean triplet only. This becomes 400. 400 plus 225 gives 625. This becomes what? 20 square. This is 400. This is 225. Which gives you what? This gives you under root 625. So resultant is 25 Newton. This is the magnitude of the force. Now one thing, class. Yes, one thing I forgot to tell you when we were discussing it. It said resultant. Resultant means direction plus magnitude. Whenever two forces are making an angle of 90 degree, let's say A vector is there, B vector is there, or any of the, let's just reverse it. Just put it in tan beta direction. Tan beta is what? B sine 90 degree plus A plus B cos 90 degree. This I forgot to discuss with you. Sine 90 is once only. B is left from here. Divided by A plus B cos theta. B cos 90 is 0, so only A is left. So this, yes, this thing I forgot to mention when we were doing that 90 degree case. So tan beta will be equal to what? F2 prime by F1. Second vector divided by the first, that is 15 divided by 20, that gives you 3 by 4. So beta will be equal to what? Tan inverse 3 by 4 is your complete final answer. This is the direction, above was the magnitude. First tell me, is it clear to all of you? Yes or no?
Yes, ma'am.
Yes, ma'am.
Devangi, did you understand?
Ma'am, how was it B by A?
B by A, yes. C, Devangi. This is a generalized formula for calculation of direction. Tan is beta is equal to B sine theta. Beta is basically the angle that resultant makes with one of the vectors. So tan beta is equal to B sine theta divided by A plus B cos theta. How did we get this? That derivation we'll discuss it tomorrow. Most probably tomorrow we'll discuss. So that on Friday's class you are at least prepared for it. So derivation, forget, remember the formula right now. B sine theta divided by A plus B cos theta. Theta here it is given in the question as right angled. Remember here, it is mentioned to you that acting at right angle. So theta became 90 degree for you. So B sine 90 is 1. So B into 1B becomes B. A plus B cos 90. Cos 90 is 0. So here it is left only A. So tan beta becomes B by A. B means a second vector. So here, what is our second vector? F2 divided by F. Clear?
Yes, ma'am.
Just note it down. Written class.
Yes, ma'am.
Let's start with the triangle law, which I was mentioning. Just write this part. This is left. Just write this. Then we'll start with the triangle law. So triangle law and polygon law derivations are not included in your course. Just parallelogram law derivations are there. That will be. Just note this down and text me done when you are done. I think all of you have written it. No? Before we begin the triangle law, just one thing you have to understand and remember whenever we are doing any law. See, what is meant by same order and what is meant by opposite order of vectors. So same order means head of one vector is colliding with the tail. Yes, I think Devangi wasn't there in the earlier classes. Devangi, when we write this now above a vector to represent any quantity that it's a vector quantity. Here this part is known as the head part and this is known as the tail. So if two vectors are in such a way that the head of one vector collides with the tail of the other vector. This is vector A, this is vector B. So they are in such a way that the head of A collides with tail of B. Then we say they are in the same order. Fine. I'll write down this point as well. Head of one vector will collide or coincide, not collide, coincide with tail of another. With tail of another. This is what is meant by this same order. Fine, same order will be used in triangles. So that's why we are just doing it in a hurry right now. Then you have opposite order. See, opposite order means what? Opposite order means just the reverse, that tail and tail are coinciding or head and head are coinciding. Not tail and tail, because if tail and tail coincide, then it becomes co-initial vectors, which is the prerequisite for parallelogram. When heads are colliding, for example, this is vector A and this is vector B. So this is known as opposite order. Here head and head collide. Head, not collide, I mean coincide. Collision is a different phenomenon. Now the actual triangle law of vector. Triangle law of vector addition. So now just remember the law statement, it is sufficient for you. Because the final formula, the formula for the direction, that is exactly same what we have been doing. That's why in the very first class of vectors, I had done the parallelogram law. For triangle law, for polygon law, just the law statement will be different. So in your exam, if you get it, everything will be same what you have studied in parallelogram law. Just you have to identify. And again, class, coming of triangle law and parallelogram, polygon law is a little rare as compared to parallelogram. So parallelogram law is often asked and frequently asked. Now, if two vectors are pointed or at a point, two vectors are there at a point, they are represented by the sides of a triangle like this. See, a triangle can be drawn like this. So one triangle, only these two are present. I'll show you. These are two vectors. This is a triangle. Agree? A, B. Now I'm just swiping this off. Earlier it was what? This was a triangle. Earlier, right now, this was a triangle. So now this here you can see we can use triangle. Now what did we do? It was a triangle initially. All of you had seen that. Now I just removed one side from there. Or now only two sides are available. So if two vectors are in such a position which represent the two sides of the triangle, two adjacent sides of a triangle, and condition is that in the same order. You can even see here they are in the same order. Head of A vector is coinciding with the tail of B vector. Then their resultant is given by the side acting in opposite direction. This is the result. This is what is meant by triangle. I'll write down the statement as well so that you understand. Triangle law basically says that if two vectors acting at a point are represented by what? Are represented by the two sides of triangle. So are represented by the two sides of triangle. Fine, two sides of triangle. But in which order? In the same order. This is a must condition for it. If they are not in the same order, don't use triangle. So in the same order, then their resultant can be represented by the closing side of triangle. The closing side of triangle taken in opposite order. The closing side of triangle in opposing order. Got it? Two vectors are there. It is acting at a point, and these two vectors are representing the adjacent sides of triangle. Initially, I had drawn a triangle. From that very triangle which I had drawn, I had cut the one of the edges. Now, if these represent the adjacent sides of triangle, then the resultant is given by the closing side, but taken in opposite order. You can see head and head are coinciding. This time you don't have to complete it in opposite way. You have to take the opposite order. So same order vectors, resultant opposite order, and two vectors should represent the sides. This is what is meant. Here, nothing difference is here. Angle, now vector A and B used to make angle, which we considered in parallelogram law. Here also, this angle that is formed, the exterior angle of the triangle, this you take it as theta. This you can take this as theta. So here resultant is what? Resultant derivation in everything is same as that of parallelogram. Here your resultant is what? A square plus B square plus 2AB cos theta, and your tan beta is equal to B sine theta divided by A plus B cos theta. How to choose beta over here? The resultant that makes with A. So here beta won't have any effect, just theta will. Fine, let's do a numerical also on this. But before that, just note down this law. Just note down this triangle law. So everything is same. So that's why your understanding of parallelogram law becomes important. Devangi, are you free tomorrow around 8:30, between 8:30 to 9? Are you available tomorrow?
Yes, ma'am.
Because just a very small class is required, just the derivation part of parallelogram, because that is very important.
Ma'am, why did we take theta as the exterior angle?
Theta is actually the angle between vector A and vector B. So how will you draw it right now between them? If you take this angle, no, this angle. This is angle that is made between the head and the tail. When we use parallelogram law or any vector laws, it's actually the angle that is made between the tails. This is theta. So here it is not possible to take theta from any of the sides. If you take theta from here, this becomes the angle between the head and the tail. But we require angle between tail and tail. See, if you just exceed it, if I just take it and bring it away, so what will happen? B is here, A will become here. So that makes the angle between them. So that's why we require this angle. Got it?
Okay, ma'am.
Regarding those classes, no, which you were saying, Aisha and Aram, that you have immediately a class after this class ends. So there is certain issue regarding the timing. I think some new classes have been added. So that's why this shifting had done to 7:30, means your 5 o'clock timers. So what we can do till the time those classes are going, I'll leave you earlier so that at least you'll have a gap of 10 minutes. You can refresh yourself, take a break of 10 minutes and then sit for the next class. Fine, till the time we are having, I'll try to do one thing, at least not exactly 5 o'clock, at least if your class starts at 4:45, 15 minutes prior to the class that has been starting, then at least this can happen 15 minutes earlier, and I leave you people most probably 5 minutes earlier, so you will get a gap of 15 to 20 minutes. This I'm talking, if this happens, then I think this will be fine for you. At least this much gap, 15 to 20 minutes gap will be enough.
Yes.
Yeah. Till the time for today's class and one or two classes, I'll leave you earlier. At least 10 minutes you will have to refresh yourself. But certain classes are coinciding because of 12th standard. Don't worry, 12th standard people are having classes from March, month of March, when your board exam also didn't start. The syllabus will get over and then it will be only 11 students, 11 class students. Devangi, you are currently in which state?
Ma'am, Uttar Pradesh.
Okay, so your 10th exam which you gave, it was CBSE board or UP board?
Ma'am, your voice is breaking. Could you please repeat?
I'm asking the board exam which you gave, the 10th board examination, it was CBSE, which board it was? UP board or which board it was?
Ma'am, CBSE.
CBSE. This question, at least you all should try change this data. Calculation will become easier. So you need to calculate more. Take this as 4 meter. Now at least you all can try and answer this question. Angle is also given. You should be able to understand at least which law should use. Quickly, calculations are now I've made the calculations also easier. Submit your answers in the chat column. Quickly. Have to find the net displacement. Yes, Devangi, good. Now put it into the formula of tan beta. Tell me what's your tan beta coming. Yes, Fatima. Right. Others also try. Good enough. Tell me the direction as well, class. See, you're just writing the magnitude. No units, no direction. Please try to write the complete answer for vectors. Put everything in tan beta. And you don't even need to put anything in tan beta. Simplified formula I told you. For 90 degree, take B by A simply. Tan inverse, yes. Tan inverse, okay. Fatima, slight error in your answer. Rest of you are correct. See how it do. Two vectors. Now they are not representing you the adjacent sides of parallelogram. Clear cut, you know parallelogram law won't be used. But at least you know the fact they are in the same order, so the resultant will definitely be given by this. And this was just the change that occurs, and you name it as triangle law. Otherwise, everything formal and everything is same as that which you have studied. Yes, Fatima. Now it's correct. Now it's fine. Because this is your beta. Right. So here resultant is what? Resultant will be simply s1 square plus s2 square. This is a Pythagorean triplet. We didn't even need to calculate. So I think most of you had answered it correctly. 4 square plus 3 square. This becomes 5 meter. And regarding tan beta, this will be a by b. So b by a, sorry. So that is s2 by s1. So 4 by 3. Tan beta is 4 by 3. Beta will be tan inverse 4 by 3. So all of you are now, I think, familiar with parallelogram. One more thing, let's just complete this also before we start with any of the laws or something. Let's complete Polygon's law as well. See, before we start with, just note it down also, all those who have not done it. But one thing that you have to keep in mind, here what happened? We took the side is in opposite order, the resultant. If you do not take the opposite order, then what happens? Then your net sum, no, that becomes 0. If 3 vectors are there that represent the sides of triangle. If anyone wants to see the solution, just let me know. Text me or just unmute yourself and ask me. See, if 3 vectors are there, fine. If 3 vectors are there and they are in the same order, all of these are in the same order. Right now, what did we do? Resultant was in opposite order. Here, let's say all the 3 vectors are in same order. For example, this is vector A. This is vector B. This is vector C. So this is your vector C. So here, if 3 vectors represent the sides of a triangle, and no need to put adjacent word over here because there are 3 sides in a triangle only. So if 3 vectors represent the sides of a triangle, then one more thing before. This is in same order. This is one of the most important things. In same order, then their resultant. Resultant sum is 0. It means here A vector plus B vector plus C vector, this is 0. Now, why this is 0? There's a derivation for it. But this derivation is not included in your course. So no need to go into the derivation, just in case, in anywhere if you see this part, anywhere. So just assume that this is what? This is 0. Fine? This is just for your knowledge. It will not be asked most probably in your exam. Just in case if it is. There's a derivation why this is 0. Before you note down all these part, let's just understand polygon law. Because statement of polygon law is just different, that makes it. Otherwise, rest of the things remain the same. So we have what? Polygon law of vector addition. Now, for polygon law of vector addition, it's similar to triangle law. Just in case, what happens is that in this you have more than 2 sides. If it is 2 sides, that will show you there's adjacent sides of triangle. If it is more than 2 sides, then that becomes a polygon law. Square, pentagon, hexagon, octagon, nanogon, all these begin. So similarly, let's say this is A vector. Then you have B vector. Till here you are allowed to use triangle law. But if I give you C vector, now what will you do? Triangle law is no more valid. If I give you one more vector D, I ask you to find the resultant of this. Neither they are representing you the adjacent sides of parallelogram, nor they are representing you the sides of a triangle. It's just the closure of this will result in, if I close this, it will result in a closed polygon. If this is representing you the sides of polygon, then the resultant is given by the closing side taken in opposite order. Whatever you studied for triangle law, all the same things are there. It's just that more than a single. So all the vector sum will be, so I'll write down the statement as well. Understand the statement simultaneously. So if vectors are acting at a point, if vectors acting at a point are represented in magnitude and direction by what? By the sides of polygon. Are represented in magnitude and direction by the sides of polygon Again, one condition that is valid for triangle law and polygon law taken in same order. For parallelogram, they were coinitial. They had the tails coincided. Here, head and tails are coinciding. So taken in same order, then the resultant is given by closing side of polygon in opposite order. Fine class. This was just a polygon law. If you had understood triangle law, this will become easier. There's a derivation, a complete derivation of this also. How to prove that a vector plus b vector plus c vector plus d vector is actually the resultant. And derivation actually includes what? It's a very long derivation. You ultimately cut it into this part. You prove the derivation of parallelogram law. Triangle law is proven by half of parallelogram law. You prove this part, then this part, this. Not included in your course, no need to go into the details. Right, so just note down this much. Solution, I think if anyone wants to see the solution, let me know till that time is right. Just text me done when you people have written it. All right, class. So, see, your extra class, not the extra class, actually, the class that had to be on Monday is postponed to Friday. You will be having a 2 hours class. I'll give you break in between, but at least we'll try to complete major portion of your vectors. So that only after one class you will be able to start with the main lesson, motion in a plane. All right, and Devangi, they'll send you the schedule for 8:30 to 9. We'll just at least discuss the parallelogram.